Now we are going to discuss about the recursive binary search. In my previous video I have discussed regarding iterative binary search. Now we will go for the recursive binary search and its time complexity. In my same elements I have taken, suppose I have taken 15 elements and which is indexed from 0 to 14 and my key value is 42. I want to search it by recursive binary search using the principle of divide and conquer, right? So what I need to do here, in case of divide and conquer, already I said you that we should have to find out the problem which is sufficiently large. If the problem is large, we have to divide it into number of sub problems, and the sub problems, small sub problems, we need to be solved. Now the problem is, how could we know that which one is sub problem or small problem? We need to be solved at single instance. So here, if the element is 1, then we can consider it is a single element and we will search our key is available that element, yes or no. Then if it is available, we will get that index. If it is not available, we will also conclude that whether it is available or not. So that is why when a problem is small, that means here in my array I have taken low value as array 0th index, high value as the n-1 index. So if this low value is equal to the high value, then there is only one element, then the problem is small, and that element is my key element or not. So first thing what I need in case of recursive binary search, I need one array, my low index, high index, and the key value what I want to search it. So these are the 4 things I need to know. So first things I have first this, let us write the function, not the algorithm. I am writing the functions. So what I did, I have taken a mid value also, integer mid. If my problem is small, only one element is there, definitely the low will be high. So if the low will be high, then I will check only for that element whether my key element is available at that index. So I checked if my key is available at array of low index, because low is equal to high. You can write as array of high, no problem. Array of low, no problem, because low is equal to high. Then we have to return that index. That index is available at L. So this index. If my problem is only one element is there and that is not my key element, then we will return 0. That means we didn't find out the elements. So for this case, we don't found. We did not found. For this case, we found only one element and that is my key element. If this is not, means the problem is not small, we have to go for the large, maybe 2 elements, 3 elements, 5 elements. Suppose consider here as 15 elements are there, we need to solve it. Our index is key is equal to 42. So what we did, we have to divide it the mid value. So mid value I have calculated low plus high divided by 2. So mid value is low plus high divided by 2, that is equal to 7. I have calculated first mid is here, mid equal to 7. Then I have to check if my key is available in array of mid. If my key is 42, a of mid is 7, a of 7 is 29, it is not available. My key is not equal to a of mid. Then we will not go through that. If it is not equal, we will go for less than. If my key is less than a of mid is 29, my key is 42, it is not less than. So definitely if it is not less than, my key will be in greater than, means right side. So what we have to do, recursively we have to call the binary search, recursive binary search. So else what I will come and I will pass what, the same recursive binary search I will call, and I will pass the array, and as my key is available in the right side, so I will take the low value as mid plus 1. So I have taken low value is equal to mid plus 1 and high is the same and key will be same. So I called this. So it will call the binary search recursively and it will pass it, and my low will be here, low will be 8, high will be 14 and mid. Now it will call this. Now this side we will consider. Which side? From 8 to 14. Now check. Array comes like this, low is equal to this, high is equal to this, and key value is 42, same. We will calculate the mid. Again we will calculate the mid. What is the mid value? The mid value is equal to 11. Now it will check low equal to high. Low is 8, mid equal, high is 14. No, low is not equal to high. That means the problem is not small. We have to go to the else part. We have to calculate the mid. We already calculated. If key is equal to A of mid, my key value is 42. A of mid is 11th index, A of mid is 47. So my key is less than 47. My key is 42 and A of mid is 47. My key is less than. So what we will go means first it is not equal to, second case my key is less than A of mid. So what we will do? We will call again we will return the recursive binary search here. Again we will call this, and what we will pass? We will pass the same array, and low value is what? High, mid value is what? The low value is the same. Low value is equal to 8. High value will be mid minus 1. Mid is 11. Mid minus 1 will be, that is, high value will be 10. And key will be same 42. Now, this, after this what will, it will go again here. Array is there, low is 8, high is 10, key is equal to 42. It will check low equal to high, low is not equal to high. It will not go here, else part. It will divide the mid. Mid equal to 10 plus 8 divided by 2, 9. Now it will check key equal to A of mid. A of 9 is 36. My key is not equal. Then it will go key is less than A of mid. My key is 42. A of mid is 36, not less than. So it will go again this part. What it will pass? Again it will pass the array and mid plus 1. Mid is 9. So low will be mid plus 1. So low will be 9. Mid plus 1, that is 10. And high will be same 10. Again whenever it will call and it will divide, now low equal to high. Low is also 10, high is also 10, and it will check A of low means A of 10. So A of 10 is 42. My element is there. It is my key value. So it will return L. L means 10. It will return an integer. So we will write here, if you will write a function, we will write integer here because it will return an integer. Now the question is here, same way we are finding, but as like iterative search is my previous algorithm, but in this algorithm recursively we have called the binary search, recursive binary search. We have passed the array, low, mid and key. The question is here, what is the time complexity for this? Now you tell me, suppose this problem, I can say that this problem is Tn, and these things will execute once, means because the condition will true means here or else will be here. This will be either the condition will be true or false. So but this condition will be true means these things will be executed once, some constant amount of time. Else cut, if it mid equal to this value, this will also return, it will also execute once. But these things, if it is less than, it will call, which one will be called? This one. And if it is greater than, this one will be. That means if it will call, it will divide the array into two parts. Here also if it will call, it will divide the array into two parts. That means this Tn can be divided into Tn by 2, and here also Tn by 2. So now to solve the time complexity of this, we have to write the recurrence relation. So let us solve the recurrence relation for binary search. Means here it will be Tn by 2, here it will be Tn by 2, but it will execute only once, because if the key is less than mid, this part will execute. If the key is greater than mid, this part will execute. So it is not 2Tn by 2. So Tn will be Tn by 2 plus some constant, you can say C, if n greater than equal to 1, otherwise if it is 1 when n equal to 1. So if you will solve this recurrence relation by using master theorem, then the time complexity for recursive binary search Tn is equal to log n. Why? Because always if you will draw the tree, you have to divide it into two parts. again it will be divided into two parts, again it will be divided into two parts, like this. So it will depend upon the height of the tree. That is why the time complexity is order of big O of log n. This is the time complexity for recursive binary search. Thank you.